All right, and I've got just about 5 o'clock, so hello IntroSecCon. My name is Chris, and we're going to talk about web apps, what they are, kind of what we can do with them, things we can do to defend them a bit. My background, I work for a small company called Counterhack Challenges, and we build mostly cyber ranges. We build games. So if you've ever been to a SANS conference and played Net Wars, that's the Core Net Wars. That's our product. If you've ever gone to the Holiday Hack Challenge, that's a free capture the flag we run every December. That's us. We love doing that and giving that to the community. That's Counterhack Challenges. We also do penetration testing. So if you need your defenses tested, let us know. I'm also in the National Guard, so I do other kind of cyber things as an Army officer on drill weekends as a part-time thing. Just something I enjoy doing, and kind of another way to serve and to do, honestly, to do nerdy cyber things. And lastly, I'm also an instructor for the SANS Institute. So when I get the chance, I enjoy going out to different parts of the country. Actually, I've also been to Canada to teach, and that's a lot of fun. I love this material. I love the whole cybersecurity field, and I'm happy to share that passion with other people. So that's who I am. Let's talk a little bit about web apps and HTTP. So we'll go through a few things. We'll talk about what HTTP traffic actually is, what it looks like, both in the browser and on the wire if you're doing any kind of like packet capture. We'll talk about the different, some of the most common requests that our browsers are sending, GET requests and POST requests, and what does that mean and what do they look like. And we'll talk about browser cookies too, and the role they play in kind of maintaining state, maintaining sessions in the web world, and a bit about how they can be manipulated. To play along, if you want to poke some of these sites, there'll be a couple things I'm doing locally, but then some of the sites I'll be poking are actually out on the internet, and you're welcome to jump out to those with me with your web browser, with something called the Developers Console in your web browser that we'll look at a bit. And we'll also use a tool called curl. It's like what web browsers looked like 30 years ago, but it's fun. And then the last tool we're going to make a lot of use of is called Burp Suite Community. This is a free web penetration testing tool that lets us do some interesting things to the web traffic to really to do kind of, well, poking. We're going to poke some web apps with Burp, and it lets us do that in a lot of interesting ways. And there at the bottom are some of the URLs we'll be going to. The last one there is not a target of any type, but that GitHub link to Mutility is a great suite of basically it's a Leatherman. It's a multi-tool of web servers that has all kinds of different flaws in it. And there are walkthroughs to talk about why they exist, how to fix them, and then actually how to exploit them too if you want to do some web app hacking. Mutility is a great tool that we'll play with a little bit. So that's it for slides. Let's play. We'll shrink PowerPoint. Thanks very much. So the first thing I want to do is show you this really cool website I built. Here's the code for it. It's pretty short. If you've never seen these angle brackets, the greater than and less than symbols, those are kind of those are the butter on the bread in HTML, right? These define all these tags that tell our browser how to render a page. So this might not look super interesting, but when our browser sees something like this, it interprets it as a website. So here's what that same website looks like through Firefox. Website, and then we see this scrolling marquee. Thank goodness those have gone out of fashion. Those were horribly irritating. And then some text at the bottom. So one more time, the code for this looked just like that. And when we're in our browser, we can actually ask it what that code looks like too. If we right-click and do View Page Source, then our browser will say, hey, this is exactly what I saw. And then that's what I rendered into this beautiful website. I don't think anybody can deny the beauty there. Now to do this, to play it at home like this, I used a very simple thing. It's a Python web server. Now, if you go out and you search for web servers, there are all kinds of Nginx and Apache and whatever else. But the simplest one to use is just Python. So you can install Python 3 in Windows, or in Linux. It's probably already there. So I'm going to type Python 3-M. That means I want to use a specific module in Python, and I'm going to use the HTTP server module, and I want to serve on port 8000. So normal web traffic, like regular unencrypted web traffic that we don't see much of anymore, would be typically on port 80. And then all the HTTPS traffic we see is typically on port 443. I'm just going to tell it to use port 8000, and then that's how I can get here to my web server. And then you can even edit in real time. Hello, IntroSecCon. Save it and then reload it. And we can see in our server here that it got 2 requests. It got a request for the slash for just the root web page, and then we asked again a few seconds later, and it gave us that same root web page. And that is the simplest form of HTTP I think we can bring up. I wanted to look at another tool too. This is curl. Curl is super simple web server. We tell it, hey, give me a website. It's on my local machine here. Localhost is a nickname for your local machine, and it's on port 8000. Please give me that web page. Now it's not going to render it all pretty like we saw in the peril of the live demo. It's not going to render it all pretty like it did in the web browser. It's just going to pull that raw text, or normally it would. Let's try. Oh, there it goes. All right. They make a lot of jokes about live demos, about how you're supposed to sacrifice chickens ahead of time or something. I didn't do that, but there we go. We got it, and it pulled that information forth. I want to show one other thing though. Curl has all kinds of options where we can modify all different parts of the request and change how we interpret what comes back. But one of the simplest and most powerful things we can do is just ask it to be verbose. A lot of Linux tools have a switch like this where you do -V, and then it gives you verbosely what went on. And let's look a little more at what happened here. So we do see the actual HTML code, right? That's the web page, if you will. But then ahead of that, we can see what our browser, in this case curl, what our browser sent to the web server. And it says, hey, give me the root of the web page. I don't want /admin.html. I don't want /kittens. I want just the root of the website. This is the language I'm speaking, and this is my this is the server I think I'm connecting to, localhost 8000. And then this is my user agent. Oftentimes here, what you'll see will be something like, Firefox or Mozilla, Safari, and lots of verbiage to go with that. Here it says, hey, I'm curl, and I'll take anything back. And then the web server says very simply, hey, okay. There's a response code here. If you've ever seen a 404 error on a website, 404 is the response code for I can't find it. 200 is the response code for you got it, here it comes. So it gives me a 200. It says, just like I told it, hey, I'm curl, it says, hey, I'm a simple Python server. Awesome, thank you. Appreciate your openness. This is what date and time I think it is. And here comes your page. And this is exactly how many bytes, how many characters I'm going to feed you back. And then we get that page coming back there. So this becomes important when we try to do strange things to websites. We want to be able to edit some of these other fields to manipulate them in a way that maybe the developers don't anticipate, so that we can do some web hacking. And that's where some of the fun is, at least for weirdos like me who are into web hacking. One other way I want to look at it while we are still on this very simple request, I want to look at this in Burp Suite. So I've got this configured to go through Burp. And I'm going to tell Burp to intercept my requests. I can't see it quite yet. So, dear web server, please give me this. So what Burp just did for me is it intercepted that request going out. So this is Firefox saying, hey, I want this root of this website. I want the slash. It's on localhost 8000. Here's my user agent. I'm using, and then all this garbage here means my current version of Firefox. If the web server wants to do something with that, it can. If it doesn't, that's fine too. And it says, here are all the ways that I'm willing to accept traffic back. It can be, different formats. You can compress it if you want. I'm expecting English if I have choices. And then there we go. So now if I want to, I can change this a little bit. Maybe I can say I'm on Windows NT 11. Take that, right? I'm on Windows 11. And then pass it forward. And then the website comes back. One other thing I can do here is I can go back through all my old requests. So this one I just sent. And here in Burp, and this is a free tool, I can right click and send to repeater. And repeater is just the a way to modify what we have and send it over and over again. So if I send it just as is and it comes back as what we expect, but maybe I say I want to get /something and send that, and then I get the 404. Or maybe I don't want something, maybe I want to just see what happens if I tell it I'm on Windows NT 1 million and just see what comes back. And it, in this case, it won't change anything interesting. But as we go forward, as we look at a few different aspects of web technology, just think about some of the different tools we have. We have the web browser, we have things like curl, and we have things like burp, and each of them plays a different role in how we interpret what's going on the website. All right, so that very quickly, that is HTTP. That's the language, Hypertext Transfer Protocol. Those are with all the angle brackets and all that. That's what our browsers talk back and forth to web servers with, and that's how we get all our cool web pages. One other thing I want to show is if we go to kittenwar.com, everybody's favorite website, I'm sure. I like to use it in demos because it is still HTTP. Most sites we go to now are going to be HTTPS, and that means encrypted, right? When it's HTTPS, that means it's going to do SSL certificates and encrypt it all at whatever level, and then we can't really see what's going on the wire. There we go, Kitten War, thank you. But when it's regular HTTP, we can. And go. I know, again, you can't quite see what I'm doing just yet. All right, so I'm using a tool called Wireshark. I think there was a track 1 talk earlier today looking at Wireshark and traffic analysis. Let's give me a JPEG. So we won't get deep into the tool, but I do encourage you to look at the other talks if you're curious about what this looks like. But it'll show us kind of in low level what a lot of these same kind of things going on the wire, and not just the HTTP traffic, but some of the other kind of funky things that servers do when they talk to each other. But anyway, another way to look at traffic is with this tool called Wireshark. If you're ever not sure what's going on in a communication, something that does packet sniffing like Wireshark or TCP dump will show you what's really going back and forth. And some people are super into that. We call them packet nerds, and we love them. All right, so let's look at something a little different. Let's talk, now that we know how HTTP works, we know how our browsers are talking back and forth. Let's look at a website who is not a sponsor of this talk. This is Hershey.com, Hersheys.com, excuse me. And we're going to talk about cookies. So an interesting thing about, let's see, am I logged in here? Interesting thing about websites and especially web traffic is that, at least as it was created, it's stateless, meaning the website, when you go to it and you say, hey, I want to go to Hersheys.com/shop, it says, here I am, and then you reload the page, or you go and you come back and it says, here I am, and it doesn't understand that you've been there before. Hi, nice to meet you, I'm Hersheys.com. Come back, hi, nice to meet you, I'm Hersheys.com. So that's why this concept of the cookie was invented. So what we're going to do here with Hersheys.com is we're going to create a new account, and let's say this is Inigo Montoya. And sorry, Hershey's, I'm polluting your database with a fake user. You killed my father. You killed my. Oops. That's a Princess Bride reference. If maybe I'm dating myself and too old here. Do a little keyboard walk for the password. All right, so I've made this new account here. My name is, oh, it doesn't like my password. All right, how about kill.com? It doesn't like my email address. Okay, don't save. Password doesn't meet the requirements. Oh, come on. I need to do more keyboard walking. And we create an account. Don't save. All right. So now it recognizes me. It says, all right, hi, you are Inigo Montoya. Thank you very much for coming to my webpage. And if I just come back to shop.hersheys.com, it remembers me. Hi, Inigo. Hi Hershey's. But if HTTP is stateless, how does it know that I am Inigo Montoya? And this is where we get back to that answer of cookies. So let's get into this. I mentioned the browser developer console. Let's get into that a little bit. Here in Firefox, and same in Chrome and a lot of browsers, if you push the F12 button, it brings up this developer console on the bottom. You can also get to it through the menus. I like pushing F12. I'm a keyboard shortcut guy. And then with that, we see all different pieces. We see a tab here that will show us all the code on the web page. This is another way to show it. It's all colorized and nice, and it collapses in trees, and we can actually change what we see in the web page here. It doesn't affect the web server, it doesn't affect anybody else's experience, but we can change how our browser interprets the website. So that can be kind of fun. With the console, you can see errors that come up from the web page. You can also give different JavaScript commands, and that's great. What I want to do right now is go to where's application? Oh, I've got stage fright all of a sudden. Where has application gone? Storage. It's different in different dev consoles. Here it's application. So storage. So if I go to storage, I can see here there are a bunch of cookies. So they've got one called create account, and then the value of that cookie is my fake email address here. And you can see that cookie is going to expire in August. And then there's another one called anonymous that blah 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 blah, and that expires in October. So as long as I come to this page and it asks me for these cookies, or excuse me, as long as whenever I come to this page, my browser will give these cookies and say, hey, Hershey's.com, remember me? I'm the guy with this cookie. Then the server can say, oh, right, that cookie, you're Inigo. And specifically in this case, it's using this DWSID cookie. So DWSID, whatever that means, probably something session identifier, then has this long, ugly value. That's great. And all that, it just uses that to key off of that, oh, hi, you're Inigo. So let me grab that value. And what we can do is we can take a different browser. So this could be a different computer somewhere else in a different house in a different country. In this case, I'm using Chrome this time instead of Firefox. And that's not F12. This is F12. And here in Chrome, we can see I've got a bunch of cookies already, even though you can see another fake account I created. So we can go in here and I can drop in. I'm going to paste in that cookie I got from my other session. So right now, it thinks, maybe it thinks I'm, someone else, or that I'm not logged in. That's fine. Now that I've set that one cookie value, free chocolate. It says, oh, hi, Inigo. Well, that's interesting. I didn't log in. I didn't use a username or password, but it's recognizing me as Inigo. And again, that's just because of this one cookie value. So Hershey's.com set that up with my other browser, said, hey, whenever you give me this cookie, I'll recognize you as Inigo. And then that cookie got lost somehow. Maybe hackers came in and stole it. Maybe I clicked on a link and it got passed around the wrong way. Now someone else got that cookie and they can log in as me, as Inigo anyway, with just that little value there. So cookies, they're an interesting piece of really bolted on technology in the web. And we see bolt-ons a lot in the internet in general, right? It started as one thing, as research network for people to share information, and there were no authentication barriers anywhere. Then we kind of had to add that on, and then we realized, oh, we need to encrypt things from A to B, because if somebody's listening in between, they can read passwords or credit card numbers. Who knew they were going to use credit card numbers across, the ARPANET, a million years ago? So we bolt on these pieces, and cookies cookies are another piece that we've bolted on to give us this feeling of having an enduring session with a site, so that we can have a shopping cart that fills up and we can check out, and we don't have to enter in our address and credit card number every time. So great that we have it, but we need to understand that it's there, and that if somebody can steal something like a cookie, then they can impersonate us. All right, so that's cookies. Let's go on to Mutility. So Mutility right here. This is a free web server. You can, if you just Google it, or I've got that link in the slides, and I'll put the slides in the Discord after this. If you go to that link, you'll go and see, kind of where that's maintained, and you can. It has instructions of exactly how to set up. Here, go download a virtual machine, download a hypervisor. There are also ways to do it in Docker, and we're not going to get into Docker and virtual machines in this hour, but there are different ways to run this site, and again, there are write-ups on how to do that exactly. So what Mutility is a collection of broken web pieces. Some of them are cataloged by year. Excuse me, the OWASP you see here, that's the Open Web Application Security Project, and it's a group of people who are passionate about keeping web applications safe. You might say, why does someone get excited about that? And the truth is, so much of what we do now is a web application. When you do a search, when you go look at recipes at Hershey's.com, when you really anything more complex than my little web page with a scrolling line about pandas, anything more complex than that is some type of web application. And we'll look at a couple more of those. But with so much of the world running on that, then we've got a requirement to keep that stuff secure, right? If we think about things like certain credit agencies that were breached a few years ago, or we hear about breaches all the time of different manufacturers and vendors, and it's in a lot of cases just because there was something broken about their web app. So people could go in and steal usernames and passwords, or they could steal PII or medical information. So thank you, OWASP, for looking out for us and trying to keep these things safe. We'll look at, within Mutility, we'll look at a couple very common vulnerabilities. The first one I want to look at is something called SQLI, or SQL injection. Now, SQL is a server query language. This is how different machines talk to each other, specifically how applications and programmers and database administrators, how they talk to databases. So databases are stores of knowledge. It could be at a library, something that keeps track of all the books and the authors and the Dewey Decimal numbers. It could be in the back end of your favorite .com shopping site that keeps track of how many pairs of medium blue pants there are in stock and what the price is. Any website or web application of meaningful size is going to have a back-end database, and the web server needs some way to talk to that database to see what's in stock and to ask, is this person allowed to log in? And the way they do that, the way they talk to that backend server, backend database, is with server query language, SQL. So one thing we like doing, we web app pen testers, we like to put in single quotes in different fields. And the reason for that is SQL uses things like single quotes to do queries. So let's take just a break from this for a second. We'll come back to Mutility. So this is the error it gave us. It said, hey, I'm trying to do this thing. Select username from accounts where username equals whatever. Now, what they were expecting here is something like where username equals Bob. And so I type in Bob or Inigo or whatever. And then when the web application tries to authenticate me, it goes back to the server and says, hey, database server, I'm looking for the username in the accounts table. So you can think of this as maybe like an Excel sheet, like a spreadsheet. So in the accounts sheet, in the accounts table, where the username is Bob. So in this case, it would be selecting Bob from the accounts sheet, right? Because username. And then once it does that, it probably has a separate query that says, oh, by the way, if the password they just entered matches the password in the database, then great, we're going to let them in. And this is normal syntax. So it's, all these commands. Select is a very common command. And then a single quote, and then my input, and then another single quote, and then semicolon. I mean, that's the end of it. So that's my whole SQL statement. That's my question to the database. What do we get back? But when we put in that single quote there, that breaks things, right? Because it's expecting single quote and some stuff, and then single quote, and then semicolon. But instead, I'm ending the single quotes early. And then instead of a semicolon, it's getting another single quote and then semicolon. And it knows that that's wrong. It's not sure what's going on. And that's why we got that error here. Hey, failure is always an option. Something went wrong here, right? I tried to do this. I got an exception. I got an error when I was trying to look this up. This is a reflected SQL injection error. We as web app pen testers love it when we get something like this. This is very verbose. This tells me exactly what went wrong, and I can look at that and go, oh, great. This is how I need to fix my command so I can break your thing in the specific way I'm trying to. And obviously, this is broken on purpose because this is a training tool. So thank you, Mutility, for making it that obvious. But anyway, so knowing this, knowing what that statement looks like, we can then say, all right, well, how can I mess with this? What if I could do something else here? What if, I don't know Bob's password, but if I could do something like, what if username equals nothing or something else, and then try to end the statement. And this is what we tend to do. So I'm going to take this. This is their question that they're asking the database. Hey, give me this. Give me whenever the username equals whatever's in the quotes, that's what I want to get back. So I'm going to say, well, you know what I really want to do is go ahead and tell me, give me back any record, any login record where the username is nothing or 1 equals 1. So how often does 1 equal 1? Fortunately, it's like all the time, right? Unless you're in some weird non-Euclidean geometry class. So 1 equals 1, that's awesome. So what this will do is when it goes back to the database, it doesn't get a match on a user, but it does get a match on 1 equal 1. So the first account it comes to is going to match 1 equal 1 and it's going to feed in that username. So to think about this a slightly different way, like let's say we did username equals John. So if we did this, or maybe Bob or John, we can see how maybe this might make sense. Maybe we want to try to log in as either person at once. So if we did Bob, and I want that in red. If we did hey, if my username is Bob or my username is John, I want to log in. Maybe I have their passwords. Maybe they have the same password, whatever. But that's not what I want. I want it to just work. I want it to just be every time that 1 equals 1 or 2 equals 2, let me in. And sure enough, if we do this in this website, so coming back to this is the field we're messing with. We can do or 1 equals 1. It's like somebody's already done this before. It's crazy. So let me in when the username equals nothing or whenever 1 equals 1, and we click login, and here we go. User authenticated. Welcome user admin. And again, this is just manipulating that conversation between the web server and a database. The designers of a website will often expect specific things to happen in a specific way, and then it's us, the pen testers, trying to act like attackers to find that risk there, to find out what people need to do to defend themselves. So that, in brief, is a SQL injection. I want to look at another thing too. Let's look at something you've probably heard of called cross-site scripting. And we'll use a text file viewer. So with cross-site scripting, there's all kinds of JavaScript that goes on in a web page. Whether you pay attention or not, you can most of the time look at the, we right-click and view source. And in most modern websites, there'll be something in there, like in angle brackets saying script, and that's where JavaScript comes in. It does lots of nice things for us. It updates graphics and passes information back and forth with the web server, does handy things. But it can also do malicious things if we are attackers. So in this website, what we're asking for is, hey, give me this text file, and whatever this is. What the designer expects you to do is to pick one of these choices and hit view file, and then it gets pulled and loaded here. So what's interesting about this is part of this is reflected. So when I pick this, there, in the background. In fact, we can look at this in the developer console a little bit because that's what cool people do, right? So I'm here in the developer console. I can look at different parts of the website. I can also use this picker here. I'm going to click the picker, and I can pick this piece here, and it zips to it in the code and says this is exactly where that shows up in the code. And I can see text file, and then here are all the different options, right? So it's a drop down there with a few different choices, and here are the choices in beautiful HTML glory. We can see textfile.com/hacking audit tool, and there's more in there. So here's the pretty version of what we see, right? This is intrusion detection, just as we see it there. But then what it's actually doing is loading this specific website. So we can modify this here. This time around, I'm going to use Burp. So let's close the developer console. I'm going to click View File, and then I use Burp to interrupt this request. So here we go. It's going to go out to my utility server, which is just on another computer here on my network. And I want to add something else here because I know, like I saw in the web page, I saw it come back with some of the text that came right out of the hidden text here in that block. Well, if I can modify that hidden text, and it's supposed to be HTTP, and this is just kind of special ways to say : / this web address. I also want it to say script alert introsec, and then I want to end the script. And this is a simple JavaScript. So hey, I'm going to start some JavaScript here. I want it to pop up an alert and say introsec, and then that's the end of my script. Now we can forward that on. So I had a request going to the web server asking for a specific thing. I'm now going to modify that a little bit, forward, and then when it comes back, there we go, introsec. So that JavaScript that I just sent out to the server came reflected back to me when it came to my browser. My browser said, oh, I know exactly what to do with this. I'm supposed to do a pop-up, and it goes bam, introsec. So to do that another way, let's do the dev console this time. So let me go to Burp, tell it not to intercept anything, to just keep watching for me. Thank you, Burp. And then we'll pick that piece again. And maybe we're going to do something a little more malicious here. And you can imagine, I mean, really, it's up to the creativity of the attacker to come up with whatever they want to come up with here. They could do anything from actually stealing cookies. We could put in some JavaScript that's going to pass the cookie off somewhere else, so that could then steal your session, like we talked about with Hershey's.com. Or we could redirect you somewhere else. So I'm gonna do some JavaScript here, and the point of this is not to teach you lfu.com, not to teach you any JavaScript here, but there are lots of resources out there to learn this stuff. All right, so what I'm doing right now is modifying my browser and saying, hey, when I pick this choice, what I want you to pick is, that textfiles.com with this JavaScript after it, and then if everything goes right, oh, it didn't. Java. I messed something up. Let me try this one more time. I'm gonna use Burp, my old standby. View file, go to Burp, and I want you to please mess me up. Script document.location equals. So I'm just saying, hey, a redirect. This is a redirect. So when we come back to this page, when this page gets served to me, I want to get sent to trail.lfu.org. And this, of course, is a bit contrived, right? I'm exploiting myself here. Forward. Oh, bummer, it didn't go. That's a little disappointing, because a few minutes ago when I tried this, it totally worked on my own. At any rate, the point of this is that when we've got cross-site scripting, that's something where we're not affecting the server at all, right? The server is just kind of a conduit in this instance. But if I can infect something else and get someone else to execute JavaScript, then I can win. So that is, let's say that I can. Maybe there's a message board. This is a common example, right? Where there's a message board and somebody posts a message and it's not filtering for characters like angle brackets. I could put in script and redirect and send you to my page. It's a lookalike page, and now I have you enter your credentials again, and I've stolen your username and password. Or I have it come to my page, and as part of the URL to coming to my page, I have it include your cookie to the first page, and that gets stored in my weblogs. And now I've got your cookie, and if I'm quick, I can hop up and use your cookie to get in as you. So cross-site scripting is a way to inject script into somebody else's browser. This is a way to attack somebody else's web session. And since, oh, you know what about happened? Oh, intercept is on. It did work. Okay, it worked, but I still had intercept on in Burp. So it was intercepting the request to redirect here to the trail. So here we are. We're at the Holiday Hack Trail. Now this is something where this is part of the Holiday Hack Challenge. So this is last year's Holiday Hack Challenge. It's still up. Anyone's free to go there and play with it. And this specific game was built just to teach people a little bit about web app hacking. Honestly, I did like a little 10-minute talk on kind of how to hack, how to begin hacking, and then built it all around this kind of clone of the Oregon Trail. Hopefully, I'm not the only one here who remembers the Oregon Trail. All right, so the idea is, oops, I see my camera's kind of lagging. I hope it looks all right on your end. You still hear me? Still hear me okay?
Yep, we can still hear you. Camera's just a little laggy.
Okay, good news, thank you. So, all right, so here's the beginning of the website. I picked easy. I can come in, I can buy different things, and it tells me how much it's going to cost. I can hit buy. Then here we go, and I'm off on the Holiday Hack Trail. And the idea is to get to the North Pole by December the 25th. So that's good. So I'm going to go back to the store. So remember, when a web server sends code, it's up to the browser to determine how to process that code, how to display it. So if we want to, we can, and this won't actually do anything super fun in this case, but just something to remember. If we want to pick something like, how much this is going to cost, we can click. I hit F12 to get in the developer console. I chose the little picker here. I clicked on the cell that I want to modify, and then it brings me right to that cell here. in the code. And then I can say, hey, browser, it looks like you are disabling that block. I'm going to just delete that part that says disabled. And then, oh, great, here we go. This is no longer disabled. This is actually going to cost me 3 instead of 37.50. And I can click buy. And then, and in certain circumstances, that'll actually get you around controls. And what this is called a client-side validation. So it's not the web server validating, the numbers that are being sent across. In some cases, it's actually the browser. It's on the client side. One case where this came in handy, don't tell my town, I registered my kids for the rec program. And as part of that, you tell them what grade they're in and their ages and stuff. And then each year, what it'll do is it'll increment their grade by 1. So my first grader becomes a second grader, my third grader becomes a fourth grader, all that. But I had a kid who wasn't yet pre-K when I registered him. So each year, when it was supposed to increment everybody, it didn't increment the youngin. So when I needed to register him for a program for which he was eligible as a pre-Ker, I went to the web page and the selector for grade was grayed out. So I couldn't change his grade unless I did this. If I just went in here and just turned off the disabled and then change his grade and then hit go, then it let me do it. Now, why they were setting it so I couldn't change a kid's grade, I'm not sure. But I didn't feel too bad doing that because they were doing client-side validation and they should sanitize inputs if that's something that's really important to them. So anyway, so remember that this is all, it's kind of like the matrix, right? Whatever your web browser sees is just what your web browser believes is there. So unless things are getting checked on the server side, then we can mess with things. Okay. Now we still got a few minutes here. So with this particular game, what we set up here is kind of a fake address bar, right? There's a real address bar up here at the top, but we added a fake one here, so we can play around with what it's like to change variables in a URL. So here we have kind of the fake URL of where we're at, and then a question mark. And what the question mark means is, what the question mark means is, hey, everything coming after this, these are parameters, these are variables. So difficulty 0 meaning easy, distance is 0 meaning I'm at the start. Can I change that to just 7,500 and then click next? And sure enough, here we go. I've only got 500 left. It was 8,000 units of distance I had left. Now it's only 500. I've made it to 7,500. So isn't that cool? What else is up in here? Money's 1,250. Nope. How about money is 12,500? And then sure enough, money's 12,500. That's awesome. Now you may say to yourself, I don't believe that this is actually a flaw that exists or ever existed. Why would anybody put variables right up in the URL for anybody to edit them? And the response to that is, this doesn't happen often anymore, but you still do see it sometimes. A lot of times it'll be with like a user ID, where you'll see, user ID, 5003 in the address bar. And in certain circumstances, you can change it to 5004 and see what somebody else is supposed to see. But we've gotten wiser and older, and we've been beaten up on that enough times that what a lot of people will do now on websites, and I'm gonna go back to the beginning here, click medium, begin. They'll take these parameters out of the URL bar and they'll move them into the body of a post request. My goodness, what is the body of a post request? Well, let's look at one. So I'm gonna go ahead and just move my sleigh along, and then I'm gonna go back here to Burp. Ooh, it blew up my Firefox. Okay, go back here to Burp, and we'll see what the post request looks like. So before we were seeing get requests, and it says, hey, give me this page, and maybe there's a parameter here. I want to be Jebediah Springfield. But then with post requests, we see just the URL, just /trail, and then all those variables, all those parameters show up in the body of the post request. So the things we saw earlier that were up in my fake URL are now down here in the body. So pace is 0, player ID, actions go, difficulty. Here's my money, 3,000. I bet I could change that to 30,000 or whatever I need. Distance, whatever I want to change the distance to. So this is more common nowadays. It's relatively uncommon to see parameters we can change right up in the URL bar as part of a GET request or whatever. That where changing them will actually make a meaningful difference, but it's still fairly common that we can go into a website and change things down in the post body, because this isn't something that people normally see, right? This is just this is all abstracted away from us. This is too ugly to show in the browser, so it's hidden in the request body, so to speak. So let's go to our intercept, turn our intercept back on. I want to go ahead and move my sleigh along, and then it gets interrupted by Burp. Burp says, hey, I'm about to send this request out. I'm going to tell the game that this is where we're at. This is their difficulty. Well, you know what, Burp? You're going to tell that we have 30,000. We're going to tell it. We can see the names of all the kids here. Let's do, yeah, health is 100. That's great. Distance, there's distance. We're going to go from 36 to 79, 90. And now you can forward that request. Now you can tell it to the server. And then, oh, hey, we're at the end. So we just won. We went 8,000 meters or miles or whatever it is here in a single click, because once again, the web server is just trusting what the client sent it. So we get our points and a verification hash, and isn't that cool? So so the lesson here for anybody working with web applications is to make sure that we sanitize user input lots of different ways, right? If we're worried about cross-site scripting, which we should be, if there's going to be any kind of reflection of user data, right? If it's a message board or something where any kind of text comes back, then we want to make sure we filter out things like angle brackets. If it's something where we're interacting with a database, we want to make sure that whatever a user puts in, if they are putting in single quotes or double quotes, that those get filtered out. And then, sorry, that's my daughter banging on the side window there. She's adorable, but well, it's been a long few weeks for everybody. And then there's another door open. She's just trying to take a shortcut. And then also we want to work on logic. And this is something that automated scanners have a lot of trouble with. An automated scanner can find things like reflected cross-site scripting, right? An automated scanner is going to send lots of requests to a website, and Burp will do this. The paid version of Burp will do this. We'll send lots of requests, and some will have single quotes. And if it comes back with some kind of SQL error, then it'll say, hey, this might be an issue, either SQL injection or cross-site scripting or whatever it may be. But these logic flaws really require humans, right? A computer is going to mess with things like the distance value and get different things to come back, but the computer isn't going to immediately understand the significance of that. Oh, this is cheating, or oh, this is a way to rob the bank, or this is a way to get somebody else's records. So web apps really, if you want to get into pen testing, I recommend you get really familiar with web applications, because there's so much ground there. In fact, when we at CounterHack, or the last company I was with, which is now Untitled Technologies, whenever we do up a quote for a pen test, web app pen testing is totally separate, right? If we're going to check your firewalls and check and see if your mail server barfs when we send weird things to it, that's fine. That's a traditional network pen test. But if you want to do web apps, that's totally separate. And we really sell it in terms of hours, not even in terms of like, we have 2 web apps or we have whatever. Because depending how complex it is, you can imagine where there are all kinds of rabbit holes you could go down and find things that hopefully that you pick up before the attackers. Oh, one more thing I want to show too. So we talked a bit about the browser just sort of believing things and how they exist, distance remaining 8,000. So I edited those that last request here on Medium in Burp, like in between my browser and the web server, which again you feel free to play with. It's part of kringlecon.com. We can do something else here. So all those variables that got passed up, right? All the distance and money and food and all that stuff, that all exists in our web page here, and it exists in something called the DOM, the Document Object Model. And this is sort of a logical way that the browser thinks about the web page you're on. It calls it a document, and it has all these pieces, and we see them here with tags and whatever. And as we go down through, we can see different elements of it, and it's super handy. If we roll over a piece of it, it'll light things up. There's one here that doesn't show up at all. You can see up on the top there, it says 640 by 0. It is an invisible thing called the status container. And if I pop this open, I can see status container, and then within this, I see difficulty, I see distance, I see money, I see health, I see all those same things I was editing before. So what if I go in here and just ask my browser, hey browser, I'm gonna change your reality. We've really got 30,000 money, and then go forward. Does that go ahead and work? And of course it does here. We now have 30,000 money because we told our web browser, hey, you've got 30,000. When you send your next request to the server, just remind it of that. Remind it that we got 30,000. And because that state isn't being maintained on the server, we can lie to it and we get through, and that's just fine. So maybe a little silly example here because it's just a mock video game that's actually designed to be flawed, but But anyway, these are real flaws that do exist in real systems and do get people in trouble. So with that, I'm going to click back over to my slides, and thank you. These are the websites we use. Again, these slides will be put up. I'll leave it on this. Are there any questions we have?
Yes, we actually have two questions so far. The first question is somebody asked if they would like to put up a box where multiple people could attack it, but it wouldn't just be open to the world at large. What would you suggest?
That's a great question. So the easy answer is, if you're at your company, it'd be great to set up a target box within your company's local network. You want to make sure that that it isn't exposed to, say, maybe your public Wi-Fi or something, because then people could. I mean, it's vulnerable. It's made to be vulnerable. Uh, but you want to be careful on how to do that. But let's say we're in a situation where no one's in the office for a few months, and you want to do it the same way. You could absolutely set up something, say maybe in a Google Cloud instance or in an Amazon Web Services instance, and then set firewall rules for it so that it blocks anybody except people coming from certain IP addresses. And you go to each of your friends and ask them for their public IP address, which, by the way, you can just Google what's my IP address. Google will tell you. And then you make exceptions in the firewall so that just those people can get to it. That's a way to do that anyway.
Great, thank you. I have one more question here for you so far. The question is, what's the Burp add-on in Firefox that you're using?
Oh, sure. Yeah. So it isn't actually a Burp specific add-on, but what we have here is something called Foxy Proxy. So maybe I should actually, let me explain a little bit about how Burp is working here. So in a normal instance, when we connect to the web, our browser reaches out to the internet and grabs a page and comes back, and that's that. What I have here, Foxy Proxy, is a free add-on that lets us specify our proxy. You can do the same thing in the menus. It just takes a few clicks to get there. I find it super handy to have Foxy Proxy to just swap back and forth quickly. So I told it, hey, rather than going straight out to the web server, go to Burp, which lives on the local system. It's going to listen on port 8080 because that's a good round number. Why not? So that whenever a request goes out, it's going to go through Burp. And you can even configure, too many windows open. There we go. And we can configure Burp to listen on different ports. Yeah, right now it's listening on 8080. So that's what that is. That is Foxy Proxy. Oh, and there's a link in the chat. Thank you. Is there a Chrome version of that? Hey, Grumpy Vader Cat. There probably is. I just punch up like proxy switcher, and I forget what it's called in Chrome, but the same things absolutely do exist in other browsers. Yeah. Can you run utility outside of a VM environment? Sorry, moderator, I'm stealing your job. I'll stop after this. I'll ask you next time.
I don't
So
mind, that's okay.
it's open and my eyes are just drawn to it because it's moving. Yeah, so what I'm actually running utility in is in Docker. And Docker is a whole separate talk. Um, in fact, the keynoter, Ian Coldwater, she's a wizard at anything Docker and Kubernetes, which kind of consolidates multiple Dockers. Anyway, Docker is this thing that it's, you can think of it as almost like a light VM, and where to run utility in a VM, you've got to pull down something like VirtualBox or VMware Player as what we call a hypervisor, something that's going to run other operating systems inside it. Then you have to pull down like a version of Linux and load that into the hypervisor and then load software into that. It can take a lot of time. With something like Docker, it was literally two commands. One to pull down the instance of Mutility, and then another one to run it, and then it's up and going. And I can't see it, like I don't get a screen like I would with a VM in a VM hypervisor, but it's got all the functionality. So with just a couple commands, I've got it running. It's running in the background, and it's doing all the things that kind of heavier VM would do. So if you just Google utility Docker, you'll see a couple commands you can run. It's got the word OWASP in it, and that'll run utility. Now Docker can be kind of tricky to set up itself, and that is another talk. But if you're in Linux, it isn't too difficult. If you're already in Linux, you're already doing hard things, so good on you. You should probably be able to get to Docker. Other questions?
I don't think we've had any other questions yet, but there is a little bit of a time delay if you want to give them a minute. I believe the next talk is not coming in for another 25 minutes.
Great.
So I think you have some more time as well.
I do see some people are typing in the chat. Kind of thrilling to see the little dots bubbling by, right?
Oh, here we go. Are there any open source analysis tools that you could recommend that would scan and flag potential common web app vulnerabilities?
That's a great question. So I usually use a paid one, so we'll skip the paid one, but OWASP has their own tool. It works very much like Burp. It's called OWASP Zap, and it is completely free. It's open source, and it does a lot of the same things. Because it's free and open source, it isn't quite as full-featured as some of the paid versions, but it's a great tool. It's something we use in SANS classes when we teach web app pen testing in the pen testing course. We use OWASP Zap. And it has something called, it's got an attack button. You put in a web address and hit attack, and it goes and checks for a lot of those normal things, right? The single quote, putting something funky in a cookie field or whatever, and it comes back with, hey, you might have this issue or that issue. So yeah, if I were to recommend one open source tool to do this kind of work, it would be OWASP Zap. So it does scanning, and it also does all that interrupt stuff that we did with Burp today. Ooh, free or low cost web app pen testing course recommendations. Gosh, I know there's a lot of stuff out there. There's some great material. If you look up any of the blog posts by Portswigger, they're the people who make Burp Suite. There's some absolute genius level web app pen testers there who put out some great blog posts. There is, if you haven't done any of this before, you're welcome to check out my CrinkleCon talk from this past December and play here with the holiday hack trail. That's something you could do to get started. That was intended to be an intro to web app pen testing. I'm sure there's more stuff out there. You'll see a little bit of it with like hack the box challenges and things like that. But I don't know of a kind of an all-inclusive, fully featured free course or low-cost course out there. Great question. And a link to Zap. Thank you. Oh, for CI/CD integrations. So the question there, looking at, they're talking about CI/CD is like the development pipeline for a shop. Like when you're building a web application to do whatever for your clients, you want to have something that's relatively easy to use and integrate into a process. So somebody has made changes to a code and somebody else has committed it to the dev environment, and then somebody runs a check on it. You can run Zap headlessly. That is, you can run Zap as a Docker container and have it check applications. So that would be one way to do that. I've used Zap headlessly a little bit with that Docker container, and it works okay. But it'll be something you'd want to play with and fine tune to get to the point where you want. If you're doing anything that is, I guess it all depends on your risk profile. Not to get too much into CISSP language here, but if your risk model is such that you're working in healthcare or you're working in industrial controls, you're going to want to have more expensive checks. You're going to want to have pen tests on your product. You're going to want to have paid scanners. But yeah, something like Zap or Headless Zap is a free way to go if you're building something like games that you're not too worried about in terms of exposure.
It looks like we've got a question about going into the service to get more training for the job.
Yeah, so I think that's a great way to go. I've been in the National Guard for like 20-something years. Makes me feel kind of old. I actually went in in the band when I was 18, and now it really just to get money for college. And then I kind of fell in love with the whole Army thing, and went ROTC, became an officer, and I've gotten to do some really cool training. I mean, back in 2002, I went to this course in Vermont where we learned Wireshark, or at the time was called Ethereal. We learned about firewalls and rootkits and all that cool stuff. And I got paid to do that training. In the last year, I've been to red on blue exercises where I ran the red team and we had this virtual network that we were attacking, and the blue teams were all looking for the attacks and trying to defend them. And I went to I got a SANS course. Like the military pays a lot of money to get trained cyber operators. So whether it's the Army Guard or the Air Guard, if you want to go and do it full time in one of the active duty services, there are definitely some options there. The bummer is there just aren't that many people who want to hack all the cybers and throw hand grenades. So it can be kind of hard to recruit for the National Guard or for the military. It's a narrow Venn diagram there. And also they're very picky when it comes to medical type things. So things like asthma or whatever else can get you disqualified pretty quick. But yeah, if you qualify for the military, it can be a great way to go to not only get training paid for, but also to get job experience, right? So many entry level jobs. I'm gonna do air quotes here in case the camera isn't catching it. Entry level jobs will ask for X number of years of experience and whatever. And how do you get that if you're looking for your first job? The military is one way to do that pretty easy. Another way, of course, is volunteering. If you want to work with, your local IC squared chapter or OWASP chapter or ISACA, whatever, there are usually opportunities to volunteer for towns and schools, and that can be a good way to get experience. But I feel I've gone a bit off the path of the question there.
That's okay. I think they were just asking sort of to get an idea of the path that you took, because I know one of the questions that has been coming up a little bit is how did you get where you are? Um, but I don't see any more questions coming up in either Discord or the webinar.
Ethereal for the win. You're old too. Well, great. Well, thanks everybody for coming and attending. If you have any questions, I think I've got my contact details in the slides there in terms of Twitter and email. DMs are open. Happy to answer questions. And yeah, go out and break something.
Thank you so much for presenting today. That was really interesting. I enjoyed listening to it.
Well, thanks again for having me.